Imagine this. 12,800 years ago, Earth was finally shaking off the grip of the last ice age. Temperatures were rising, glaciers retreating, massive animals roaming vast plains, and early humans, the Clovis people in North America, thriving as skilled hunters with their distinctive spear points. Then, almost overnight, the world plunged back into cold. Temperatures in the northern hemisphere dropped sharply by up to 10 degrees Celsius in just decades. Ice advanced again, sea levels fluctuated wildly, and entire ecosystems collapsed. This mysterious cold snap lasted over 1,200 years. Scientists call it the Younger Dryas, named after a small Arctic flower whose pollen suddenly spikes in ancient lake sediments during this freeze. What caused such a dramatic reversal when everything pointed to steady warming? For decades, the leading explanation has been a massive flood of fresh water from melting ice sheets disrupting the Atlantic's ocean currents. But a bolder theory claims something far more catastrophic. Fragments of a disintegrating comet exploded in the atmosphere over North America, unleashing firestorms, shockwaves, and an impact winter that triggered the cooling. This is the Younger Dryas Impact Hypothesis, and it's one of the most debated ideas in modern archaeology and climate science. Let's start with what we know for sure about the Younger Dryas itself. Ice cores drilled from Greenland's summit reveal a razor-sharp shift. After thousands of years of gradual warming, the climate flipped. The North Atlantic's powerful conveyor belt, the system that carries warm tropical water northward, weakened or nearly shut down. Heat transport to the poles stalled, plunging the region into near-glacial conditions. Pollen records from Europe and North America show forests retreating, tundra expanding, and the sudden return of cold-loving plants. In the oceans, shifts in plankton and isotopes confirm the abrupt change. This wasn't a slow drift. It happened fast enough to reshape human survival strategies and wipe out dozens of large animal species. The mainstream view pins the blame on meltwater. As the Laurentide ice sheet over Canada melted rapidly, huge glacial lakes like Lake Agassiz burst their ice dams. Fresh water poured into the North Atlantic, forming a cap of lighter water on the surface. This fresh layer prevented salty, dense water from sinking, the engine of deep ocean circulation. Without that sinking, warm currents couldn't flow north, and the northern hemisphere cooled. Computer models support this. Simulations show that enough fresh water from outlets like the St. Lawrence or Mackenzie rivers could weaken the Atlantic meridional overturning circulation by 20 to 50%, matching the observed cooling. Recent studies even point to pulses of meltwater from the Greenland ice sheet and Laurentide Greenland systems contributing to periodic freshening in the Labrador Sea. But not everyone is convinced this explains the full picture, especially the speed and scale of extinction. Enter the comet theory, first proposed in 2007. Supporters argue that a large comet fragmented as it approached Earth. Pieces exploded in airbursts, no single massive crater needed, scattering debris across the northern hemisphere. The blasts ignited continent-wide wildfires, lofted soot and dust into the atmosphere, and caused rapid ice sheet melting that flooded the oceans anyway. Proponents point to a thin black mat layer found at dozens of sites across North America and beyond. Dark sediment, rich in charcoal, soot, and unusual materials dated right to 12,800 years ago. Inside this layer, they've reported microspherules, tiny melted glass beads formed by extreme heat, nanodiamonds, shocked quartz grains fractured by intense pressure, platinum and iridium spikes suggesting extraterrestrial material, and high levels of biomass burning markers. Experiments show these could come from airbursts similar to the 1908 Tunguska event, but on a much larger scale. Some studies from 2024 and 2025 claimed shocked quartz and metallic dust in eastern US sites, and even ocean cores from Baffin Bay near Greenland, hinting at cometary debris reaching the seafloor. If true, the impacts could have triggered massive wildfires that darkened the skies, cooled the planet temporarily, and accelerated ice melt to flood the Atlantic, combining cosmic catastrophe with the meltwater mechanism. It might also explain why megafauna like mammoths, saber-toothed cats, giant sloths, and short-faced bears vanished so suddenly across continents. Over 35 genera disappeared around this time, many in North America, where the proposed airbursts would hit hardest. The Clovis culture, known for hunting these giants, fades from the archaeological record almost immediately after. No more Clovis points appear. New tool traditions emerge. Some researchers suggest surviving humans adapted by shifting to smaller game. fishing, and even early plant cultivation, perhaps planting the seeds for agriculture in places like the Fertile Crescent. The idea is dramatic, and it's gained traction in popular books and documentaries. But the Younger Dryas Impact Hypothesis faces serious pushback from much of the scientific community. Critics argue there's no confirmed crater or consistent global evidence for such a large event. Many of the claimed markers, like nanodiamonds and microspherules, have failed independent replication tests or can form through ordinary wildfires, volcanic activity, or sediment processes. Shocked quartz, once a key smoking gun, has been questioned in some analyses. A major 2023 review called it a failed hypothesis, pointing out methodological issues, irreproducible results, and logical gaps. No clear link to widespread human population crashes or extinctions beyond natural climate stress. Even more recently, in early 2026, two high-profile papers claiming ocean sediment evidence for cometary dust and shocked quartz were retracted from PLOS One due to concerns over data handling, methodology, sampling errors, and misleading citations. These retractions dealt blows to newer supporting claims, though proponents argue the core evidence from land sites still holds and that debates continue with rebuttals and ongoing research. So where does this leave us? Meltwater explanation remains the consensus for the cooling, backed by ocean models, isotope records, and no need for rare cosmic events. But the impact hypothesis keeps the door cracked open. Intriguing markers persist at some sites, and the synchronicity of extinctions, black mats, and Clovis decline is hard to ignore completely. New sediment studies and better dating techniques could tip the scales either way. What does it all mean for human history? If the comet theory has merit, a single cosmic event may have reset civilization, ending one era of big game hunting and forcing adaptations that led to farming, settlements, and eventually the world we know. Even without it, the Younger Dryas shows how fragile our climate system is. One big pulse of fresh water or atmospheric disruption can flip the planet from warming to ice in a human lifetime. What do you think caused the Younger Dryas? Was it just meltwater disrupting the oceans? Or did a comet play a role in one of history's greatest resets? Drop your thoughts in the comments. I read them all. If this deep dive hooked you, check out my short for the quick teaser version, smash that like button. If you're into ancient mysteries, subscribe and hit the bell for more breakdowns like this. Next, we're tackling the sea people. Stay tuned. Thanks for watching. Don't forget to subscribe to History Retold, and we'll see you in the next one.